Civilization has been shaped by great scientists discovering basic principles. Give me a lever long enough and a fulcrum on which to place it, and I shall move the world.
This lesson today will be simple machines and looking at first-class levers.
STEM education encourages students to experiment, collaborate, and create. At North Elementary in Cedar City, Utah, Ms. Gina Bellamy's mixed second and third grade class explores a simple machine essential in mechanical engineering, the lever. Ms. Bellamy's students experiment with first-class levers, adjusting the load and moving the fulcrum to different positions beneath the beam in order to identify principles of work, force, and leverage.
We're also going to integrate some math into some graphing of what we find out in our data, and they're just going to be little scientists today. When I say fulcrum, when I use the word fulcrum, what is a fulcrum? Just what did we go over yesterday? What is a fulcrum?
It's something that balances something else on it, and it's under the middle.
Okay. Does anyone want to add to Riley? So he said it's under the middle of something, and it's something that something else balances on. Orlando?
It's trying to balance out the load and the force.
So somebody tell me what our force is. And we have another word for force as well, right? To help us remember what force is. So tell us what force is. Maddie?
The work that you have to do to make the load move.
Good job. It's the work. The force is the work. So in the middle of your circle map, you have lever, okay? I'm going to set our timer. 1 minute by yourself. Everything you know about a lever, okay? Anything you know. Your task today is to come up with the answer to the question, how can we use simple machines, but a lever, because there's many different types of simple machines, a lever to make our work easier. All right, let's build our lever first. Out of your bag, will you take out what you think is the fulcrum? And will you hold it up for me? Don't eat it. This is our lever. So hold this up so that you know what you're working with. Okay, now where do you think your fulcrum's gonna go? Knowing what a fulcrum is, where are we gonna put it?
We're going to put it right under here.
Okay, and can it go in different places? Anywhere underneath, right? We have our first measurement we're gonna do is at 6 inches. So will everyone do that and then check each other that your fulcrum is under 6 inches. There's 2 pieces that are gonna be your load. Your load is the cup that is at 11 inches. Okay, so put your load in your cup that has the L on it and make sure they're flat. What do you notice about your cups?
I noticed that this one is heavier and this one's lighter, so it goes straight up instead of this, and it's all balanced.
Seisha, what did you notice? What did you notice about your cups and your lever right now?
They're not tipping straight like this. The load is down and the force is up.
And now our job is to see how many number of paper clips, that's going to be our force, our work, it takes. So you want to just place your paper clips in nice and gentle, and you want to count as you do it. And when it tips down, you're going to stop and record how many. Okay, tell me how many. Raise your hand.
3.
What?
23.
Okay, we got 23, 24, 22. We're all pretty much the same, right? I want you to gently take your paper clips out. Somebody tell me if the fulcrum now is closer to the load or closer to the force.
The load.
Okay, it's closer to the load. The load, are you ready? You're gonna do the same thing again. Paper clips. Oh my goodness. That is way less. Think about what you just learned. So when you're at 6 inches, it took 23, your force was 23. You moved your fulcrum to what? To 8 inches, which was closer to the load, and it took way less.
Ms. Bellamy's class performs the task again, this time moving the fulcrum back to position number 4, much farther away from the load.
Oh my goodness.
Woo! Did that take a lot of work? Wow, that took a lot of work. Someone tell me what their number was.
64, 66, 56.
I hear a lot of 56, 57, so we're gonna go with, this is our official one up here.
Ms. Bellamy records the class results on a bar graph.
Fulcrum positions, that's where we put our fulcrum. So where was the first place we put it?
6.
6 inches, right? Elise?
8.
When your fulcrum is close to the load, do you have to work harder, more paper clips, or work less?
It's easier.
It's easier, right, when the fulcrum is close. So now knowing that, let's look at 5. Put your fulcrum at 5. Now you're gonna make a really good guess. Are you ready?
Ms. Bellamy's students use what they've learned about levers to make predictions about how many paper clips it will take to lift the load, as the distance varies between the fulcrum and the center of the lever.
Good, Seisha, see? So at 6, you had 23, right? And that's closer to the load. Now we moved it further from the load, and so you're going up to 30, which is probably gonna be pretty close. Good job.
29.
What you're noticing is that it was further away. Orlando, what did you predict? Tell us what you predicted and why you made that prediction.
I predicted 35 because the more farther it is from the load, the more paper clips it takes.
Okay, the more work it's gonna take, right? What else did you get? You can shout it out.
37.
37, I hear, 36, 38. We were all right around 35. We'll make 35 our official number.
After the students have tested their predictions, Ms. Bellamy presents a final example to reinforce the concept of fulcrum placement.
Where does that fulcrum need to be? Does it need to be way down on the force end? Does it need to be in the middle? Where would it be the easiest to lift me?
It would be easiest near you.
Right? Because didn't we find out that the closer it is to the load, the easier it will be to lift? Push.
You'll be amazed.
Did they lift me?
Yes.
Was it really hard or not so bad? Not so bad. Will you move that log
Want it closer to
closer to them? Yep. Should they be able to lift me?
Yeah.
What do you think?
Yeah.
Some of you say yes, but it's further away from me, right? Okay, go ahead. Okay. Is it working? No. Okay, guys. But was it easier when it was closer to me?
Yeah.
Okay, I want you to take out your science journals. Add to your circle map, because now you know more about a lever. On your page next to that, I want you to write one I wonder question. We do I wonder questions so that we can come back to levers and maybe challenge ourselves with something different about a lever.
I wonder how many different ways you can make a lever.
There are probably other ways we can do it, right? And we're gonna engineer those Friday, actually. We are gonna make our own levers.
56.
Keep going.
57.
I learned better when my teacher let us just do the experiment and figure it out ourselves.
I think they did a great job. And I think they, for the most part, learned what I wanted them to learn.
I learned that when the fulcrum is closer to the load, then it will be a lot easier to lift up, and when the fulcrum is closer to the force, then it's going to be harder.
And so we try here at North to just make it as much hands-on as we can, and it works, and they love it.
I want to be a teacher and teach kids science.